All right, recording should be started. There you go. We are live. So let me get started with just a few slides, clarify a few things, okay? And then we're going to do live coding on a fake exam to help you prepare for the upcoming real final exam, okay? So, like I said, a few things to get started. I'm going to make sure first that I can keep an eye on the chat window. There we go. All right, so Michael, if you have problem understanding series of transform, don't worry. This is what we are going to cover today, okay? That's why it's in the slides. So we're going to go over this, and then we are going to work together on series of transform, which is going to be our fake exam, pretty much. All right, so last call for the student evaluation. The reason for which I'm still mentioning it is, and this is the last time I mention it, by the way, if you get sick and tired of hearing me, like bring that back up. The deadline is this Friday. Okay, so after this Friday, you will have lots of chance to have your voice heard. So please make sure you bear that deadline in mind if you have not taken yet the evaluation. If you have, a big thank you for your feedback. All right. Ground rules for the final exam. So this is the last chance we have to discuss a little bit how the final exam is going to work. So please don't hesitate to interrupt anytime and bring up your questions. Okay, if anything is unclear, we clarify it right now today. So the day for the exam is Sunday the 5th, noon 30 to 2:30. We knew that already, okay, for a little while. What's new as of yesterday, as a matter of fact, is that we finally have been assigned a room to take our final exam in. So this is going to be ISA 1051. So this is an interdisciplinary science building. It's not too far from engineering, but I've never used actually 1051 in that building for a final exam, so I'm not sure exactly what to tell you about the layout, okay? I'll try to look it up sometime during the week, but I encourage you to try to do the same thing. So that brings me to the second point, which is, I told you all along, you'll have to bring your laptop for the final exam. Make sure that you have a battery that can actually last you comfortably for at least 2 hours, okay? Uh, I said no plug available. If we have plugs, I will be more than happy to use them. Oops, we are like scrolling way too fast through the slide. Sorry about that. Let me fix that and rewind a little bit. There we go. So if we have plugs in the room, it's not that I'm against you using them. It's just that there are never going to be enough plugs for all the students. Okay. So I encourage you to contact me if you do not have a battery that's going to last you 2 hours. Try to find like a solution, borrow a laptop or something like that just for the day of the exam. Okay. Bring an extension cord just in case. But again, I want to reiterate, if one or two students have a problem and they notify me, I'm going to try to make sure that those students are sitting near a plug. If the day of the exam I end up with like 30 or 40 students that all tell me I need to plug in, we cannot accommodate that. We cannot make that work, okay? So that's why I want to give you a heads up way in advance. All right, the exam will be taken with Canvas, so it's meant to be very, very, very extremely similar to the IEs in terms of format, okay? So that you won't have any like last minute weird surprise, etc. Honor lock will be used, albeit a little differently than we have been using it for the IE, but it's still going to be proctored by honor lock. You'll have to upload your Java file, bring your student ID just in case, okay? Just in case we need to check it through honor lock, or just in case we need to check it even in person during the exam, okay? If you have time accommodation, I already mentioned that, but this is my last chance to try to reach out to everybody. If you have any form of time accommodation, please make sure you work with your SAS liaison to be scheduled in a separate room at a separate time. The issue with the room that we have for the final exam is that we never know how long we can stay after the end, okay? Sometimes there's no other final scheduled in that same room for 1 hour. Sometimes it's 2 hours, sometimes it's 30 minutes. Okay. So the deal is pretty much we don't own the room, after our official time for the exam is over. So I cannot grant you accommodation in that room. So as soon as you get it scheduled with SAS, you drop me a notification, drop me an email. They will contact me as well. And I will set the deadline for the final to the day and time that is necessary to make the SAS schedule work. Okay. So we'll work this out together. Don't worry, but be diligent about it. Okay, do not wait the last minute to schedule your accommodation, because just like everybody else on campus, I'm sure these folks are overworked, so they might be overwhelmed at the last minute. IE4 is meant to be graded before the final. Yeah, absolutely. In case you want your feedback a little earlier and not wait for the end of the week or something like that, then I would advise you to contact your grader and meet with them during the office hours to go over your exam. Okay. If anything, that would make them actually boost your grading to the top priority of their list. Okay, and ensure that everybody has had their feedback before the final exam. All right, good question. What else? So that's it for the logistics. Important things, what is allowed, what is not allowed. Question first in the chat, my laptop doesn't have a webcam. Do I need to bring an external for unlock? Send me a Canvas message, Ryan, okay? I think I have one other student that is in a similar situation than you, so I'm going to handle that and get back to you ASAP, okay? I should be able to get back to you later tonight after I'm done with my office hours. So drop me a Canvas message so that I don't forget, and I will get back to you. So, exam ground rules. We have been over that for mostly the IE, but I want to have a slide so that everybody can refer to it and know where to find the detail about the final. So what is allowed during the exam? One laptop. So I wrote down one laptop only, no extra computing device. So you're not going to use your cell phone or your tablet or whatever during the exam. It's just you, your laptop, and the exam, okay? The textbook is allowed, whether you have a digital version or a print version, that's okay. The PDF of the slide is allowed. You can save the files on your laptop. You can access them in Canvas during the exam. This morning, somebody asked me if it was okay to print out the slides. Yes, it's okay to print out the slides if you want, if you prefer, as long as you do not annotate them, okay? Having the slides, the PDF of the slide allowed is not the same thing as having personal notes. The IDE of your choice, again, I recommend JGrasp. If you have been okay with JGrasp all semester, this is your first course in Java or something like that, then please, by all means, do not switch to a more advanced IDE just at the last minute, right before the final. I've seen that happen. Generally, that doesn't go too well. So I don't want anybody to lose points, because of some shenanigans due to their IDE or something like that. That would be really disheartening for everybody involved. So stick to whatever you have been using this semester. If you are already using IntelliJ, whatever, NetBeans, Eclipse, Visual Studio Code, insert here the name of your favorite IDE, right? If you are already using those things and you are comfortable with them and you know how to use them, then by all means, feel free to use it also during the exam. If you need some scratch paper, pencil, pens, etc., bring that the day of the final exam. You are absolutely allowed to use this. What is not allowed during the exam? Let's start with the easy answer. Anything that's not explicitly allowed. If I have to update the list of what is allowed because somebody brought up a question or asked, for something to be allowed, and I think it's fair, then I will post a Canvas announcement or a Piazza announcement. So you'll hear from me in writing pretty much, okay? But otherwise, anything else is not allowed. Question in the chat, can we write down page numbers to refer into the textbook to find some quick syntax? No, that would be a note, personal note, cheat sheets or stuff like that. So what I would suggest to do instead is use bookmarks. Okay, use bookmarks on your textbook, like little colored tabs, and you can write something on the colored tab because it's not going to be a lot of text, right? But otherwise, bringing another piece of paper with written stuff, handwritten or printed, that is beyond the scope of what I described above, no, it's not going to be allowed. What else? So the three things that I mentioned here, earplugs allowed. Allowed. Okay. The earplugs, no, not if they are like electronic. If you want just like earplugs to cancel out completely the noise, like good old-fashioned earplugs, then sure, why not? If you want like earbuds and stuff like that, no, because that can be a form of communication. So yeah, it's very strict, but final exam generally are, okay? So talking about strictness and stuff like that, preventing Honor from monitoring you, as usual, this is a big no-no, okay? That will get your final exam worth 0 points, and it's 30% of your grade, so be careful. Communicating with someone else or accessing website? Of course not. This is personal work. We're trying to assess your performance, okay? So even Googling is a form of communication, by the way. You are trying to search for answers to questions that other people posted on the net, so this is not allowed either. And finally, personal notes. And this is a question that comes every semester. Can I bring Java files, that I wrote myself during the semester, or that I downloaded, for example, the example from the textbooks, or whatever else you can possibly find out there that could be relevant? And the answer to that is a big, simple no, because I've seen too many students, gather like a gigabyte of a code example before the final, come to the final, and then waste 2 hours, trying to search for those code example, desperately trying to find, something that will allow them to write the final. We have been training all semester long, writing code from scratch, okay? And this is exactly how you're going to be evaluated for the final. So with the textbook to remind you of the syntax, with the slides and the examples in the slides and all that good stuff, you are going to be okay, all right? If you forget something, you will be able to find it back in the documentation. Of course, if you forgot almost everything and you have to look up almost every bit of syntax in the textbook, then you are going to waste a lot of time, okay? But the occasional, I don't remember how this method works, or I don't remember what are the available methods in a release, for example, that should not actually kill your exam. So you will have the textbook and the slide to help you with that. So just make sure you know the layout of the textbook, the layout of the slide, okay? Sooner, Andres was asking about writing the number of the page. There is an index in the textbook. There is a table of content. You can add bookmarks if you want, okay, little tabs, color tab, etc., with a title on it, or a word, a keyword, or something like that. With that kind of system, if you prepare before the final, you'll be okay. Okay, you are not going to lose points because you forgot something. And that's the goal. This is not a memory test. This is a test to know if you know how to write code pretty much from scratch using the techniques that we studied this semester. All right, what else? That's it for the logistics. So now we can dig in. So here's the menu for today. I already uploaded the slides. I uploaded also a file named, let me give you the name here real quick. Where is it? The file is named COP2513 Final Exam Review.java. It's located in a new module called Final Exam Review. So if you go to Canvas, and I invite you to do it right now so that you can get set up for the session, go to Canvas, go to our modules section, go to Final Exam Review. That should be the last module of the list. And therein, you're going to find the first Java file that you can download is COP2513 Final Exam Review.java. So download it right now. This is going to be what we are going to work with all together during this session. So what is this? This is pretty much a fake exam. Okay, this is what I call review exercise number 1 in the slide. It's a fake exam, but I need to clarify something that I also clarified to your classmates this morning. This is a little longer than the final exam will be. This is a little bit more difficult, maybe. That can be subjective, but this is definitely organized in a way that is going to make you scratch your head a little bit more. And I don't mean just the difficulty in terms of understanding the concept that we taught, but also it's going to force you, for example, to react to compilation error message and stuff like that. So is that the plan for the final exam? No. The plan for the final exam is the final exam will be in line with what you have grown to expect, in the intermediary exam all semester long. However, this is our last chance for practice. So I really try to use this fake exam as an excuse to work in all sorts of different topics into it, okay? So sometimes that may feel a little bit artificial, but that's the point. The point is that if I had a choice between making the program look good or adding a little feature that is maybe not necessary, but that allows me to review with you specific syntax or something that I know that students tend to forget by the time we reach a final exam, then my priority was definitely that, okay? So it's about the size of a final exam. It's about, again, the complexity of a final exam. It's definitely going to give you a good workout before you take the final exam and force you to kind of remember some things that might have slipped in the back of your mind. Okay, so that's the whole philosophy for this session. This morning we were able to do about, I would say, half of it, two-thirds of it. I don't know exactly. There is no rush. Okay, we had a lot of questions this morning. We interrupted the flow of the session to do some screen sharing with students that had related questions. The bottom line is that this is our last chance together to catch any misconception that you still have, any difficulty you have with a topic. This is our last chance to actually address it and try to make you comfortable before the final exam. Okay, so that's the top priority. I'm going to work through that code with you, but if at some point we have to take a side remark, to address a question, do a little detour, then we will definitely do that. Okay, we have done a ton of detours this morning. For those of you who want to check the video, please feel free to do so. This is probably questions that you have also, but don't hesitate to interrupt. Don't hesitate to bring up your question in the chat window. I'm keeping an eye on the chat window. If I miss your question, don't hesitate to bring it back again. I'm not going to ignore any single question today, right? Usually I don't do that, but I mean, point is, if I don't answer your question and I move on to the next topic, but you type something in the chat window, please remind me, okay? All right, what else? So let's dig in. Let me try to give you an overview of what we are going to do. So I'm going to switch off the slides because everything that is in the slides here, see, this is all the description of everything that has to be done in that fake exam. So there's quite a bit. Okay, but granted, the description are always verbose. Okay, I try to make them as exam-like as possible, so they are indeed verbose. And then after that, there is a second exercise, which Michael was mentioning at the beginning. The second exercise is about the temperature data store. That one is simpler. That one is simpler. That one is shorter. So the bottom line is we are going to spend as much time as needed on the first fake exam. And then this second example, this second review exercise, I will leave it for you to do on the side if you want to, or if we have time, we'll do it together towards the end of next session. Okay. And if you bump into a problem, of course, you bring that up to any of the office hours, and the TAs and myself will be more than happy to help you out through that one as well. But that one is a little bit more, I would say, concise. Okay, less voluminous, requires less scratching of your head. So that's why I don't have a problem leaving it as an extra exercise if you need extra practice. But if you go through the fake exam that we're going to work on together today, and you are okay with that, then you are ready for the final exam. That's the goal. Okay. So let me close this because everything that's in the slide is actually in that file that you just downloaded. So again, if you came a little late or whatever, there is a file named COP2513 Final Exam Review.java. Here I named it Final Exam Review PM.java because we're going to work on it together this afternoon. If you are curious to see what we did this morning with your classmates, you can check out the video recording for this morning session, and you can check out the COP2513 Final Exam Review AM.java file that is pretty much where we stopped at the end of the session. Okay, so let's take a look overall at what we need to do. So we have a main class. First remark, everything is in one file. Okay, so that doesn't mean necessarily this is what's going to happen for the final, but I want you to be used to both ways of organizing our code. Okay, every class in one file or every class in its own file. We have been going back and forth all semester long between the two approaches, so you should be comfortable with both. So here we're just picking one kind of at random, everything in one file. So I have a public class, only one public class per file, that's the rule, and it's called COP2513 Final Exam Review PM. Inside that class, which is going to be my main class, a main. So unlike the final exam, we are going to spend a little bit of time today together writing actually the contents of the main. So the comments are telling us what the main should be doing, but we are going to have to fill in the blank. During a final exam, during an IE, generally I give you the content of the main method, okay? So you already have a minimum amount of tests. Here we are going to write our minimum set of tests ourselves, okay? But we have instruction to guide us and to help us do that. So the role of the main is going to be, as always, to execute, to create object of the various classes that we have to write, and call method on those objects, make sure that everything is working. So we have a bunch of instructions here that are going to tell us step by step what we need to do. So right now, I'm not looking at the details. Right now, I just want to give you like an overview of the file, okay? The second thing that we have in the file is a class named series of transforms. So here's what's going on. We are going to write a class, series of transforms, that is going to contain a list of what we're going to call string transforms. And actually, I've been using this morning. I realized that this morning, but I didn't want to change it because you are going to have to change it alongside with me. I'm using the name string transformation and instead of string transform. So I'm going to abbreviate it as I go. Okay. So first modification you have to do in your file, line 61, where it says string transformation, please shorten it to string transform. And then we're going to do a global, query replace. But right now, let's just take care of this line since we are here. So that series of transform class is a container for a list of objects of type string transform. So what is a string transform? A string transform is going to be an object that represents a modification, a transformation that you can apply to a string. For example, if I give you a string that say hello, and I tell you I want to apply a transformation on that string that transforms every lowercase character into its corresponding uppercase character, well, then I would give you the string hello, H-E-L-L-O, lowercase. I would ask that object of class string transformation to apply its transformation on the string, and the result out of it would be hello, H-E-L-L-O, but this time all uppercase. Okay, so we are going to model in a class named string transformation. We are going to model all sorts of transformation that can be applied to a string. Uppercase to lowercase, lowercase to uppercase, what else? Reverse the string, stuff like that. Okay, anything that you can think of, we could implement it with the class string transform or one of its subclasses. Okay, as a matter of fact, string transform, is going to be a class that implements a very basic transformation on a string. It takes a string and it leaves it unchanged. Okay, so this is a minimal transformation that you could ever possibly think for a string. Okay, and then we are going to have subclasses of string transform that are going to be actually doing things like reversing the string, etc. Do you suggest reading over all the methods for our final exam or just go at it one method at a time? I do suggest, it's a very good question. I mentioned that this morning to your classmates. I do suggest that you take 5 minutes to read all the commands. So what I'm doing right now for you is I'm summarizing what you would learn if you were reading all the commands from the start to the end of the file. And when you do this first reading, don't get too worried about details, okay? The idea is really to get a feel for how much work is going to be required of you and what kind of work and what is the meaning of the main classes that you're dealing with, okay? If you can get all of that in 5 minutes at the beginning of your final exam by just reading the whole thing, okay, then you're good. This is going to be very helpful to help you navigate. And then after that, you do one method at a time, you do one task at a time, okay? Generally, that's how it's been going for the IEs. This is how I try to organize as well the final exam. This one here is going to be a little bit more, go here, go there, run here, run here. But again, this is part of the practice. So this is not the kind of stuff I would expect from you as a final exam. So right now, I'm still summarizing, the overall idea here, what are all the classes we are dealing with and what they're meant to do. So we talked about string transform. So we know it's going to be a superclass. There are going to be two subclasses, one called reverse transform and one called letter transform. And they are going to just implement very specific types of transformation that we can apply on a string. You'll see more about that when we go into the detail. But right now, a series of transform is going to be pretty much an array list of objects that represent transforms. And we have polymorphism here rearing its head because we have an array list of string transform, and I already said string transform is going to be a superclass that accepts subclasses. Okay, so Why do we have this container? Well, we have this container because we are going to store inside of it a succession of string transform objects which represent operation to perform on strings. Okay, for example, I could say first step, reverse the order of the string. Second step, convert uppercase to lowercase. There we go. That's a series of transforms. It has only two transforms, but it tells me what transformation to apply first step, what transformation to apply second step. So this is what the series of transform class is going to model. And what we want to be able to do, we want to be able to call the method apply in a series of transforms on a series of transform object. And we want to give it a string like hello. And it's going to apply the first transformation on hello, get a result. Now it's going to take that result as the input of the second transformation, apply the second transformation, give me an output. That output, sorry, is going to be the input of the third transformation if there is one, and so on and so forth. So we are going to pass our string through each of the transformation one after the other, every time taking the result of the previous one as the input of the next one. And at the end, we are going to get the final result here that is going to be returned by this method. So right now, the implementation that I have for the apply method in series of transform is just doing pretty much nothing. You give me a string as input. Well, sure, I have not implemented anything, so I'm going to give you back that string right away. So it doesn't do anything useful, but at least it compiles. Okay, like if you try to compile the code right now, yes, it's compiling, not doing anything useful, but actually it's not compiling because I just modified something. I modified string transform, so I'm going to come back. But if you try to compile it before to do what I mentioned and modify line 61, then it should still be compiling. Okay, so never mind about this. We're going to get to that in a second, literally. So we have this apply method, and similarly, we have an undo method. So if my first step was reverse the string and then transform lowercase to uppercase, I'm going to get a final result. If I feed that final result to the undo method, and I tell it to undo all the steps in the series of transform, it's going to start by the end, undo the conversion from lower to uppercase. So that's going to convert uppercase to lowercase. Then it's going to undo the reverse, and then it's going to provide me the result, which should be the original string that I started with. Okay, so it's kind of like a conveyor belt system, you know, where you have a workstation that each do something on some input. Here, these are strings that are going to pass through the series of transform and be transformed by each of the transform one after the other. Okay. So that leaves us with, we have pretty much covered almost everything here. We are going to have a class string transformation. And actually, again, modification, line 118, please modify this to string transform. We're going to do a global search and replace anyway at the end, but since we're here, let's do that while I think about it. So string transform here, public, not public, class string transform. This is going to be where I try to implement everything that has to do with applying a transformation in general. And there is going to be some stuff, like, for example, you can see here, we're talking about timestamps, okay? We are going to talk about log files. So every operation that's going to be applied to a string is going to get a log entry in a text file by the time we are done with this whole final exam, okay? But this is pretty much one of the main piece of work in this particular exercise, okay? The class string transform. And then once we have written the 4 or 5 methods that are in this class, okay, you can see here that we are going to record some log data at some point into a text file. Once we are done writing the code for this class, there we go, we are going to have 2 more classes that are going to be extremely short. So these are going to be a lot shorter, but it's because they are subclasses of a string transform. One of them is going to be called reverse transform. And I'm going to say here that it extends string transform. Okay. And the second one, I'm getting rid of that here because it's really like literally just 2 words to add. The second one should have this already written. Let's check. The second one is class letter transform extends, again, string transform. All right. So let's go back to the beginning of the file. And I would suggest that everybody does it at the same time that I do here. We're going to make sure that we cut all of those renaming, okay? So if you go to your left panel here, normally by default, it's on the Browse tab. Click the Find tab. And here what you're going to type is string transformation. This is what we did this morning with your classmates, okay? I'm going to find all instances of string transformation in one word and replace it with the name string transform, okay? And that's going to kind of homogenize the way that things are named. It's going to make things a little easier in the long run, okay? So I go to the beginning of my file and I click on find, and it's going to tell me that here, apparently all the instances of string transformation have been already replaced. For example, here there was one, it's been replaced. For you, depending on whether you were able to follow up with me or not, you might have a few more to query replace like that. Please do so now so that we get rid of it, okay? And now that all of those have been replaced, let's see what the compiler has to say. Compiler is happy. So I'm going to pause here, okay? And anytime during the session, you know that you can interrupt, you know that you can ask me to go slower, to scroll back up so that you may see the modification that I did somewhere in the file. Ideally, I want you to follow along. Okay, so I don't want to go too fast, but if I go too fast, please, I count on you to let me know, okay? So right now, I just want to make sure everybody is done with this first overview. If you have any question about what we are trying to do at a high level, in this code, please ask them now. If you have any question about, what are the modifications that I just did to the code, ask them now. If it's not compiling on your side, please let me know, and let's use this as a milestone checkpoint to get everybody on the same page. So Michael, you had a question?
Yes. So which button did you click did you click replace all or replace?
I clicked find. I like to do them one by one, and then I click replace. And then find again for the next one, then replace. Or you can use replace, then find. It's up to you.
Okay.
So quick question to highlight what I've been working on pretty much. Only this modification here, Aaron, okay? So this everything that I've done, modified in the file so far, has been pretty much replacing this word by this word, with one exception, and I'm going to go scroll to that exception and point it out to you. Give me one second. Blah, 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 blah. This is here. I added also this on line 242. There you go. And so far, I promise you, this is all I modified in the file, okay? So you should all have a file right now where we rename string transformation into string transform, and it should compile, okay, without errors. It's not going to do anything. If I try to run it, it's really not going to do anything on the screen, okay? That's okay, because everything is a dummy implementation. But you should be able to at least compile. And yes, Control F is probably a shortcut. Okay, I'll try to, yeah, there we go. Control F to find. It's going to also bring up the panel. All right. So I'm going to wait just a few seconds. So if you need me to wait, say something, raise your hand like Michael just did, ask your question, and once I run out of question, I'm going to move forward. What's up, Michael?
It's not working.
Okay. What are you getting?
The screen flashes blue each time I click find.
So when it does that, like for example, like this, right? That means that it cannot find any more instances of string transformation. So that means pretty much you're done. Okay? You replace everything that had to be replaced. See, it's doing the same on mine. All right?
Gotcha.
All right. So again, anybody else? We're good? All right. So moving forward. So we have kind of a high-level overview here. Things are going to get more concrete now as we write together the main method. And that's one of the reasons for which I wanted us to write the main method in this particular exercise. So I'm going to move all of this out of the way so we focus on the code. Okay, so if you work ahead and run into a different error, let me catch up with you, okay, and then bring up your question when you bump into that error, okay? When we are at the level of where you're getting the error, I mean. So for the final, for the COP2513 final exam review PM file, we're going to start with the main method. And the first task that we are assigned is for 1 point, declare and initialize a string constant reference variable named log, referring to the string literal log default.txt. And I'm going to cut and paste this so that I don't misspell it. And then what you have here is a little bit of flavor text. Okay, so flavor text is not telling you what to do. It's trying to tell you why you are doing this. Okay, so it's explaining here that this constant is going to hold the name of the that our application will use by default. So if we don't change that log file, that's going to be a log file called log-default.txt. And it continues to tell you, since we're going to pass that string as parameter to many methods, we're going to define it as a constant. We could also define it, just store it in a variable and reuse that variable. The constant is just, to be honest, to make sure that we have at least one thing that makes us review the final keyword in Java. So quick question in the chat, is there a way to import util and IO with one line? Nope. Those of you who were like looking at the beginning of the file, generally, this is where I tell you, oh, by the way, add here any import statement that you need. I kind of use the shortcut version here, where I import everything from the package util and everything from the package IO, so that I don't have to constantly go and add, a new import statement every time I want to use, for example, array list or whatever. But there is no way to do it in one single line. Somebody this morning was asking, can you do import.java? And I was curious because I didn't know if Java was actually a package itself, or if it was just the root of the other packages. And if you try to do this, well, the compiler is not going to be really happy with you. Import.java star is not going to work out. But import the name of a package and then followed by dot star, yes, absolutely, that works. So you could here use those two lines to make sure that you import everything from util and IO packages, for example. Okay. So going back here to our first task, this is really what I have to do. Okay. Declare and initialize a string constant. So how do I declare and initialize a string variable? That's really basic, or it should be basic by now. Okay. I'm going to call it string. They asked me to call it log uppercase. We use uppercase when we spell out a constant, so that makes sense because eventually we want this to be a constant, and we want it to be equal to, well, this. There we go, double quote here, and then the name that they gave me. I just pasted the name they gave me. So that's a variable, and if I want to make it a constant, I just add the final keyword in front of it. Save and build. Like I said this morning to your classmate, compile all the time. You finish a statement, compile every time, so that you avoid having a lot of syntax error to track down for like an entire half an hour or something like that. Okay. So here I just did something very simple. I got myself 1 point. So my objective is to try to net all the easy points first, and then to leave the stuff that's going to be a little bit more complicated for the end. You are going to see that this is going to work for the first two tasks, and then the compiler is going to start yelling at me. So when the compiler yells at me, then I look at the compiler error message, try to understand them, and do whatever I need to make the compiler shut up, pretty much. So part of it is going to be driven by my need to get points. The next part is going to be driven by my need to make the compiler tell me that I wrote good code. Will we be able to edit the restriction of the variable, or will it be strict to private, public, protected? So I will always ask you when I want an attribute, I will ask you for that attribute to be protected, private, or stuff like that, okay? We have encountered one time, I don't remember if it was a practice exercise or an IE, we have encountered a situation where I asked you to make an attribute private, and then later to answer another question, one of the possible ways to answer that question was to go back and change the attribute to protected. So that can definitely happen, okay? What happens is that if you have the attribute private, you'll get full credit for the first question. if you went far enough in the exam and you ended up solving that later question and you had to switch it to protected, you will get full credit for both questions if you switched it to protected. Okay, the TAs will know what to expect. All right. Okay, no problem. So what do we have here? We have a second task that should be okay. So this is what we have to do. Create an object of class series of transform, and then the flavor text. That class is going to be the one that models a series of successive string transformation. So I already covered that pretty much. I already explained, okay? But this is where you would learn it in an exam situation by reading, an overview of all the commands in the file. So right now, since we spent already a little bit of time, explaining what was going on at a high level, right now I am left with a very simple task, which is just create an object of a given class. So how do I do this? I'm going to write series of transforms, and I'm going to call my variable SOT, series of transforms. Not trying to be original here, and it's going to be new series of transforms, and then right now, I'm going to put empty parentheses because I've not been told anything really about the constructors for that class. Okay, so that's it. So that's already 2 points. Not a bad start. Let's save, let's build, and let's move on. All right. The third one. So the third one is going to, you can tell already it's getting longer, right? It's not that complicated, but it's going to make us jump all over the code because the compiler is going to yell at us. So get ready for a quick review on compiler error message and what they really mean. Okay, that's the reason for this little diversion here. Now, in a final exam, I try to write final exam and IEs so that you can complete progressively all the steps and you don't have to jump back and forth too much, just to make it a little streamlined. But in this case, it's not going to be streamlined at all. It's going to serve us as a hard, pretty much review of how to deal with compiler error message. So you should be getting a sample of the compiler error message that you have seen all along the semester and that you have a good chance to see also during the final exam. Yeah, absolutely, Andreas. I can scroll back up real quick. This is a line that interests you, right? The series of transform. So as you guys are following along, please do not hesitate to tell me to wait, scroll back up and stuff like that. We are not in a rush. The goal is really to leave room for all the questions and leave room for you to experiment and pretty much practice today, okay? I jump to string transform. Would that be the next best place to go because a release is a list of string transform objects? So yes, that's actually the natural next step that we are going to go to. But here, as I start, referring object of class reverse transform, letter transform, and string transform, what you are going to see happen right now is that as I create objects of those classes, the compiler is going to yell at me because I don't have constructors. Okay, so I'm going to go, this is what I was mentioning about jumping back and forth, right? I'm going to write the code that is asked of me here, and as soon as I'm done, I'm going to have to go and jump to those classes, this one, this one, this one, and add the constructors. So pretty much we are going to follow your footsteps. We are going to go into string transform very, very fast, okay? So let's take a look at what we are asked to do here. We want to call the add method on that object. Well, what's that object? This one here, okay? So we just created an object of class series of transforms. We are going to call its add method in order to add several objects of the class string transform or one of its subclasses. And we are going to pass those as parameter to the add method. And then the instruction go on to tell you, by the way, you know that log variable that contains the name of the log file, you need to pass it to every constructor of those classes. Okay, so that every object that is created right now is going to be told pretty much what is the name of the log file for the entire application. Okay, so let's go. Let's dig in. First object that I need to create a reverse transform object. So how do you create a reverse transform object? You say reverse. I'm going to do it 2 different ways, right? Reverse transform. I'm going to call it RT1 equals new reverse transform. And then the instruction told me something about you need to pass the value log each time. Okay, so I'm going to pass log to that constructor. And this is where things are going to start going south. Okay, so once I created the object, then I want to say SOT.add and pass that object to the method. Okay, I could do it like that, or I could do something like SOT.add new reverse transform log. And that's exactly the same thing. Okay, the only difference, so there is a little difference, not exactly the same thing. The difference is that here we save the reference to our new object, and then we pass the reference to the method add, but we still have the reference inside the variable RT1 in the main. Okay, but in this case here, I create the object, and I don't save the reference. I just pass it directly to the SOT.add method as a parameter. So I don't have it anymore in the main, but since we're not going to use those references anymore in the main, I'm going to actually comment out those guys because they're kind of a little bit more verbose, and I'm going to use this form instead. Okay, but I want you to understand that at the end of the day, whichever way you write it is okay. You're going to get the same job done. Now, if I try to save this, saving is going to work, but as Riley mentioned in the chat, if I try to compile this, we are going to start getting into trouble. So what is it complaining about? It's complaining about constructor reverse transform. Well, yes, I am using a constructor reverse transform. In class reverse transform, so that's a little pedantic and redundant, right? Because the constructor reverse transform will always be in the class named same as the constructor, cannot be applied to given types. So you have encountered this. We have seen it in lecture, in live coding and stuff like that. I want you to be ready for that compiler error for the final exam, okay? That happens every time you try to call a constructor, but Java looks at the class, so reverse transform. So let's scroll down and look at the class just like Java is doing, okay? So this is series of transform as keep. This is string transform as keep. This is, the next one should be reverse transform. There we go, reverse transform. So Java looks in here and say, I see a method apply, I see a method undo, and that's it, no constructors. So do I have a constructor that can accept a string as parameter, a one-arg constructor that accepts a string? No, I don't, and that's my problem, okay? So I'm going to fix that problem very simply. I'm going to go into this class here, reverse transform, and I'm going to say public reverse transform. So I'm declaring a constructor. More specifically, I want a constructor that takes one argument, and I want that argument to be of type string. Okay? And there we go. So I'm doing this. I'm not done, okay? I'm going to do more things in that constructors. But right now, I'm just doing the minimum amount of work that I have to do so that the compiler allows me to call this constructor here. Okay, so saving, and we're not done following the trail of compilation errors. Okay, but for now, I did what I had to do to make the compiler accept that line. So, question about constructor is always same name as its class? Yes. Quick refresher, real quick here. If I have a class named reverse transform, the constructor is also called reverse transform. It's public. We've never played with protected or private constructors. You never have a return data type, so not even void here, nothing. And then you have the parameter for your constructor, and then the curly braces for the code. Okay, so these are the rule, the syntax rule for constructors. All right. So now that I have this empty constructor here, well, that's letting me compile that bit of code. So I'm going to keep moving forward. And every time I bump into something that the compiler is not happy about, I'm going to scratch my head a little bit, and I'm going to figure out what it's complaining about and try to fix it. So I had to create a reverse transform object. Here we are, and add it to my series of transform object. Here we are. Now I'm going to do that again, but this time I need to create the second one is a letter transform object. So let's come here, cut and paste oriented programming for the win. letter transform. So I create a new letter transform. I pass again the name of my log file, and I add that new object to my series of transforms. Okay, this is what they're asking me to do. Right. Okay. Try to save. Saving is never an issue. Try to build. Well, again, so what is it this time? Constructor letter transform in class letter transform. Hey, that sounds familiar. Cannot be applied to given types. Again, same thing. So I'm trying to create a constructor here that takes one arg, and that one arg is of type string, but Java was not able to find one. So let me go to the class letter transform. It's completely at the end of the file. So I'm going to scroll down real quick, then scroll back up a little bit. There we go. Letter transform extends string transform, and it doesn't have a constructor. So you know what? I'm going to give it a constructor right now. Public letter transform string the name of the log file, and that's it. Control S and Control B. All right. So I allowed actually the program to compile. My constructors are empty. I need to fix that. Okay. By all means, I'm not done, but at least I'm able to work my way through the main and keep, like getting those points here for those simple creation of objects and have my code compile. So what is the next step? The next step is going to be a string transform object. Okay, so be it. So let's take this. Let's paste it again. And this time it's a string transform. Here we are. Create a string transform log. So by now you should get bored of it, right? What's going to happen? Compiler is going to say the string transform class doesn't have a constructor that accepts one argument, blah, blah, blah. So it's always the same problem, right? So I'm scrolling down to string transform class. There we are. It's the next class in line. And yes, it doesn't have a a constructor, sorry. There is a comment here that say, oh, we need a 1arg constructor and a 0arg constructor. Okay, sure. So I'm going to put my constructor after this command. Okay. Public. The name of the class is, I forget. The name of the class is string transform. So public string transform takes a string log as parameter and does nothing for now. Okay. Save and build. All right. So there's still something wrong, but this time it's hopefully a different problem. Okay. So let's see what's happening here. An error on line 257. This is at the beginning of the reverse transform class. This is where I wrote my constructor. So like 5 minutes ago, the compiler was okay with my constructor there. Okay. Now it's complaining. So what is it saying? Constructor string transform in class string transform cannot be applied to given types. So don't let that fool you. It's a very similar error, but please observe that the error occurs in the class reverse transform, and yet it's complaining about a constructor for string transform. So what's going on here is that when you have an empty constructor like this, what's done automatically by Java? Yes. Okay. So quick reminder, if you do not explicitly use super and parentheses like that as the first statement of your constructor, or this and parentheses like that as the first statement of your constructor, automatically Java will insert for you a call to super empty parentheses. So what's wrong with that? What's wrong with that is no, override will not fix that because we're not overriding anything yet. What's wrong with that is that you are in the class reverse transform, okay? You extend string transform, you call super without parentheses, so you are calling the noarg constructor from your super class, string transform. Well, let me take a look at string transform. What kind of constructors do we have? So I'm scrolling back up at the beginning of string transform. There we go, line 128. Then I scroll down. Ah, here's the constructor, the one that I added. Okay, but it takes one argument of type string. Do I have another constructor, like a noarg constructor? No. So that's what it's telling you. It's telling you inside this code here, there is a call to super that you don't see, but Java, you know that Java inserts it for you. There's a call to super, and it refers to a no-arg constructor that doesn't exist currently in your super class. So how do I fix it? And Michael had a suggestion in the chat window that I'm pretty fond of. I can fix this by saying, instead of calling a no-arg constructor that doesn't exist, I saw that I had a one-arg constructor. So let me call that one. And it fits very well because you give me a log, the name of a log file, and that one-arg constructor from the superclass expects also the name of a log file. See how this is like all fitting together nicely? This is awesome. So that means that now I'm properly chaining two constructors, okay? And I'm giving them actually the same bit of information, which is the name of the log file, and I'm passing it from the subclass to the superclass so that we can save that information in the attribute of the superclass. Okay? All right. So far, this is working okay. Except that we have to pretty much understand what the compiler is trying to tell us, so that we are able, to add just enough code that it compiles and can actually be run, even if it doesn't do yet much. Okay. What else do I have now? So I fixed that problem, but it's still complaining. Again, do not simply ignore the compiler error message. It's telling me again about the constructor string transform cannot be applied to the type that you gave me, and it's telling me the problem is right here, line 293. So I'm double-clicking line 293. Hey, this is exactly the same problem. Okay. If you understood the previous one, this one is exactly the same problem. Right here, there is an implicit call to super. Super is a call to a no-arg constructor. There's no no-arg constructor in string transform, but fortunately, there is a one-arg constructor that takes a string as parameter, which is supposed to be the name of the log file. So I'm going to take the name of the log file that you gave me and pass it to my superclass constructor. Okay? So far, so good? I'm trying to compile in the background. It's compiling now. All right, so I'm going to scroll back up to the main. So where are we at now? We have been doing like what, 3 of those object creations? Yeah, 3 of those. So we've taken care of this one, this one, this one. So now I have another reverse transform and then yet another. Yeah, question in the chat. So why is explicitly calling superlog doing? So what is it doing? So it allows me to take the log. It's taking the log that you're going to pass me. Let me show you, okay? Let's say here I create new reverse transform, okay? I'm in the main. I pass as argument the log. This is a variable that is defined right above, a few lines above in the main here. So this is a default name for the log file for this application, okay? So I call reverse transform, the constructor, with log. So let's go to the class reverse transform. I'm scrolling down. Pass series of transform, pass string transform, and then I find reverse transform should be about here. There we go. So you gave me as argument, right, the name of the file, the log file. So I receive as a parameter the name of the log file, and I call it log, but this time lowercase, okay? What am I doing with it? So reverse transform is a subclass of string transform. What I'm going to do is I'm going to do something with this constructor eventually, but right now the only thing that I have to do is pass to my superclass the same data that you gave me, so that the superclass constructor is also aware of what is the name of the log file for this application. And if I go to my superclass string transform, so let me scroll back up, going up, 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 string transform should be about here. There we go. The class string transform, if I look for it, it has one constructor here. This is a constructor that I'm chaining with. And this constructor is going to receive also a copy pretty much of the string that represents the file name for the log file. Does that make sense? What we did this morning, we ended up doing at the end of the session, we ended up doing a quick review on constructor chaining. So if you guys want me to do a quick review on constructor chaining, we can definitely do that. I'll keep going through the code here, but at the end of the session, remind me, and we'll take a very simple example that we'll build together from scratch, okay? But right now, I want to make sure that in the context of this application, you pretty much, you and everybody else see what's going on, right? We have a log file name. We pass it to our constructor. If that happens to be a constructor for a subclass, that constructor passes it also to the constructor for the superclass string transformation, okay? So if super is automatically used, why does it not compile without log? Because when I do super like this, let's go and take that example here. Right? When I do super like this, okay, I'm calling a superclass constructor that takes no argument. So now the question is, in the superclass string transform, is there such a constructor? Is there a no arg constructor? Let's double check. String transform, scrolling up. There we go. This is a class string transform. I'm looking inside of it. I find one constructor here. It takes one arg of type string. Then I find a method apply, a method undo. I find a method get result. I find a method record log data. I find a method write log data. Oh, that's it. So I don't have a no arg constructor. So when I try to do this, what the compiler tells me here is on line 258, there we go. On line 258, you tried to call a no arg constructor, but I could not find one. That's why we had to do all this. So now I'm looking inside the class and I realize there's only one constructor which takes one argument, and that argument is the name of the file, the log file. Guess what? Perfect. I have the name of the log file here. I can pass it. Yes, constructor, well, it's not exactly match. Okay, for example, here in reverse transform, I could have another parameter called another, right? And what you do is you call your superclass constructor, one of the available superclass constructor, and you give them whatever information they need, whatever information they want. So here I know that they want the name of the log file. I'm going to give them my first parameter. That doesn't mean that I cannot have another parameter here in reverse transform, right? Matching would mean that they are exactly the same. They don't have to be exactly the same. It's just that your subclass constructor has to gather enough information from whoever calls it so that it can pass to the superclass constructor the information it needs. And in this case, the superclass constructor says, I need you to give me a log file name. Does that make sense? Cool. So good question. This is a good review of all that constructor chaining stuff. Like I said, if you guys want like us to take separate examples that are not necessarily as involved and complicated as the one in this fake exam, we can also do that at the end of the session. Okay, it's easier to understand sometimes a concept on a small program that's like 5 lines long than to try to understand it in the context, of a larger application. So here I'm going to undo this change that I made just to make my point, and I'm going to make sure that stuff is still compiling. Awesome, still compiling. Very good. So I'm going back to the main now, and I was almost done actually with that task. What I need to do now is I need to create a reverse transform and another reverse transform. Okay, so no problem. I can do that. I can do that using the power of content-based oriented programming. There we go. I create 2 reverse transform objects, and I add each of them to my series of transforms object. Okay. Control S. So now we should be okay because we already took care of fixing reverse transform. Yes, Michael?
Yeah, I was just wondering why my letter transform is not working using that context or syntax, because what I have here that works is the old one that was more verbose, the one that has 2 lines of code versus your 1 line of code. Yeah, like that one.
So it should work even if we do the 2 lines of code. Okay, so let's do that together. I'm going to comment out this line, and I'm going to say instead, so it's a letter transform. What is the problem that you get, by the way? Is it a compilation error?
Yes. Yes, it is.
What does it say?
1 second while I uncomment the.
Mhm. So this is what it should look like, and most of the time, what happened is just a little typo, in the name of the class or something like that would throw off the compiler completely, right? So depending on the error message you get, that might be just what's happening. I'm trying to compile this, and yeah, it's working. So you can go either way. While you check your code and let me know what compilation error you get once you have a chance, I'm going to answer Brian's question in the chat. How would I display the two new added reverse transform objects if they aren't given a name? So none of these guys are given a name, okay? By given a name, I mean, assign them to a variable, a reference variable. But what we do is we add them one after the other to the object that represent a series of transform, and that object is going to keep them inside an array list, okay? So the first one is going to be the first one we add is going to be the first element of the array list. The second one we add is going to be the second element of the array list. That's how we are going to keep track of them, okay? So they are not lost. From the main perspective, I didn't keep them, but I'm not going to need them anyway. All I want to do is build that huge series of transform, and then I'm going to only use a series of transform, okay? So that will make sense like that. Meanwhile, Michael, did you find your compilation bug there? A compilation
Yeah,
error
all is
message?
good. I think it was just a minor tempo.
That's okay.
Typo.
Yep, that happens all the time, and that's why I tell you compile all the time, so that if you compile all the time frenetically, generally the typo is in what you type in the last 30 seconds, and it's easier to find that if you type an entire page of text and then you get a compilation error. Some of them can be nasty to troubleshoot. Okay, so same thing here. I'm going to command this so that we have the same approach everywhere, and I'm going to uncomment that one. And we are good to go with that task, I think. Let me double check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, we created 5 transformation objects, and we added them to our series of transform objects. So now our series of transform objects, if we inject a string inside of it, it's going to first reverse it, then apply something that I don't know yet what it is, but it's called a letter transform. Then it's going to apply a string transform. Then it's going to reverse it again, and finally reverse it again. So is there less memory usage when you do it like this? Yeah, a little bit. You save yourself one reference variable. Okay, it's not a big deal. I don't think anybody during your curriculum with us at USF is going to actually ask you to optimize to that level, to save like a reference variable. But yes, you are actually not using this variable here, so you are saving a little bit of space. Now, the reason for which a lot of people do not care about this is that when you compile your code, there are a ton of optimization that the compiler does for you. Okay, so there's already a ton of things that are being done for you in terms of optimization. So chances are that the difference between this and this is not going to even be noticed once your code has been compiled. And can I summarize what this code does a little bit slower? Yes, absolutely. When you mean this code, you mean this one here, the one that we just wrote, right? Okay, no problem. So what I was saying is that we created 1, 2, 3, 4, 5 objects. And those objects are of type string transform or one of its subclass, letter transform or reverse transform. Okay. Now I added them all to the series of transform objects, which means inside of series of transform, there is an array list. Okay. And that first object is first in the array list. That second object is second, third, fourth, fifth. And that represents like a chain, okay? Like a chain of operation. So when I'm going to, and you're going to see me do that next step, okay? But when I'm going to try to apply my series of transform to a string like hello, for example, what it's going to do internally is going to apply the reverse transform to hello. So that's going to give you O, LL, EH, okay? And then it's going to feed that to the later transform that's going to modify it in a different way. The outcome of that transformation is going to be fed to the string transform that's going to again modify it, and so on and so forth until we reverse it again twice at the end, and then I'm going to get my output, my final result. Does that make more sense? This is a big picture. It's like the series of transform is like a factory, series of machines, and then I have a conveyor belt, and the conveyor belt is going to carry a string, and each factory machine is going to modify the string and pass it to the next one, modify, pass it to the next one, modify, pass it to the next one. So right now we are just setting up pretty much the series of transformation, and then we are going to start using it. But before we use it, the next task asks us to call a method validate on our object of class series of transform. So that's going to be SOT, right? So this is what I have to do. This is the flavor text. The flavor text says the validate method, and we're going to talk more about it when we implement it. But the validate method is there to look through an entire series of transform and try to warn the user if we do something a little bit fishy. Like, for example, if you reverse a string and then later you reverse it again, chances are that those two operations cancel each other, right? So the general idea, what we are going to check with the validate method is if in a series of transform, I have an even number of reverse transform object of class reverse transform, then doing an even number of reverse, most likely they cancel each other out. So I'm going to display a warning to the user. Now, there are certain situations where it's going to be perfectly fine, right? But I want to detect that possibility and display a warning to the user if I detect it. So how do I do this? SOT.validate. That's it. And if there's an even number of reversals, it's going to display a warning message on the screen. If not, then it's not going to display anything on the screen, and we are good. Okay? So that one was easy. Next one, last but not least, call the undo method on your original series of transform objects, so SOT, and pass as parameters the following string. And there we have like a string here that is completely, it looks random. It doesn't look like it makes sense, but it does make sense. I'm going to explain in a minute. Okay, so I'm going to cut and paste it because I don't want to have to retype that. So on SOT, I'm going to call a method undo. So the apply method processes a string throughout the chain, right? Throughout the series of transform. The undo method is going to process a string in reverse order through all of the series of transform, and it's going to apply at every step the undo step. So you pretty much undo all the transformation that the series of transform is capable to do. So SOT.undo, and then we pass that string. So what's the story with that string? What does it mean? Well, when this fake exam was prepared, I took this exact same series of transform, the one that I asked you to build in the main, and I gave a string to it. And I called SOT.apply so that the string would go through all of the transformation. This was the result, the end result of the transformation of that string. Now, what I want to do is I want to know what is the original string that was given. So somebody told me this is the result that I got. Okay, I'm going to feed it to the undo method, and it's going to ask it to undo all the transformation that have been applied on that string with that series of transforms. And that is going to give me back the original string. What am I going to do with the original string? I'm going to display it on the screen. So system.out.println, okay? And I'm going to display whatever this method is going to return to me, which is going to be a string, okay? So what I should see on the screen is, once I'm done implementing everything, this code should display a message, which is human readable, which is plain English, and which is a sentence, a phrase that was transformed by this series of transform when the exam was returned. So it's almost almost like a cipher, okay? But it's really the dumbest cipher that you will ever encounter. It's not even as good as a toy cipher. So I really am reluctant to call it even like a cipher or use the word cipher to characterize that. It's just a series of transformation on string. Somebody applied them to a message. Now we are going to decode that message with the same series of transformation that they told us to build in the main. Okay? All right, so let's see first if that compiles before everything else. Okay? So it's compiling. We are pretty much done with the main. So we create a series of transform. We add to that series of transform a bunch of objects that each represent a possible transformation on a string. We validate to check if there is an even number of reverse operation. And then we ask that series of transform to undo all those transformations on a string that is a result of a secret message that was on which the string of transformation was applied off screen. Okay? And now we're going to decode that. All right. And we're done with this. It's the main class. So now we're going to talk about the class series of transforms. So this is the one that contains all of those, this array list pretty much of objects that each represent an independent transform. So we start by saying it extends array list of string transforms. So for the final exam, watch out. We've learned to do two things with array list. Okay, one is inherit from array list of something, and two is use composition, that is create an attribute of type array list of something. So both are fair game, fair play for the final exam. I just picked one here at random. So here I decided I was going to inherit from array list of string transform. Okay, but I could have written the same program using instead an attribute inside the class series of transform that would represent my list. And I would have declared that attribute as an array list. Okay? So I want to make kind of like refresh your memory on the two different things that we've seen through exercises. Now, what are we going to do exactly? Well, for 3 points here, we have a first method called validate. And the instruction tells us this method will iterate over the array list and count how many of the objects inside the array list are of class reverse transform. Okay, so I need to look at every object in an array list. That's a job. Yes, exactly, Andres. That's a job for a for loop. What kind of for loop, actually, to be more specific? What kind of for loop would you guys use? Well, yeah, it's going to be a for loop that iterates over object. There we go, bingo, for each loop. Okay, so just because the for each loop is the most adapted to doing like a very simple iteration from start to end of an array list. Okay, so we're going to use that as an excuse to review the syntax of for each, make sure everybody's okay. At the exam, if I want you to use a for each loop, I will probably tell you explicitly to do so, just so that you understand that you get full credit if you use the simplest way to do something, and you get partial credit if you make a more complicated than necessary solution to a problem. Okay, so here I want to go over every element in my array list, and I want to ask every element, are you of class, reverse transform? If yes, then I count it. Is one more. If no, then I don't count it. Okay. How do I ask an object if it's of class reverse transform? You guys remember? Yeah, bingo, Ryan. Instance of. Okay. So, all right, it's starting to kind of like get together here, the structure of this thing. Okay. So I'm going to say, okay, I need a counter. So int n equal 0 to start off with. Okay. And then at the end, what they tell me is that if I encountered a number of reverse transform object that is greater than 0 and even, then I want to display this message on the console. So I know there's going to be a system.out.println somewhere. Okay, so let's go for it. System.out.println. And that system.println is going to display on the screen that particular message that was given to me in the instruction. So there you go, cut and paste. And it's going to do so if and there are going to be two conditions that need to be met. Okay, so if one condition and another condition, there we go, and then if that is true, send out that message. What is the first condition? N is greater than 0. Okay, that's what I'm told to do here, right here. And then if it's even. So how do I test if it's even? So n modulo 2. So modulo, that means a remainder of the integer division, okay, equals 0. If the remainder of dividing n by 2 using an integer division is 0, that means n is even. And yes, I added this to the fake exam just so that I could refresh your memories about the modulo operator, because that's something that we used early on in the semester, and it's really easy to forget about. Those who took COP2513 with me, we used it enough that you probably will never forget about it, but maybe some of you did. So in that case, this is a quick refresher, okay? So if n is greater than 0 and n modulo 2 equals 0, then display, oh, something is kind of weird in your chain of transforms, okay? But now I'm left with the core of the method to write, okay? The core of the method is I need to actually go through that list, and I need to look at every object. And if the object is an instance of reverse transform, then I increment my counter n by 1. So let's take a look at how this is going to look. So we said we are going to use a for each loop, okay? So what is the type of the object inside my array list? It's string transform, okay? So I'm going to say for each string transform. How do I know this, by the way? Let me scroll back up real quick. Here, I said it was an array list of string transform. So for each string transform, and I'm going to call the variable that I use st for string transform, inside the array list. Where is my array list? Yes. Okay. Remember, I inherit from the array list class, so the object itself is the array list. So for each string transform in st inside the array list does, what do I have to do? If statement. If that statement is true, then increment n by 1. What is the statement going to be like? If st is an instance of, and then reverse transform. There we go. Okay. So look at every element in the array list. Test if they are an instance of reverse transform. If they are an instance of reverse transform, increment by 1 the counter. That looks like we are pretty much capturing the essence here of those instructions. So let's save this. If it builds, compile. Okay. So now they're on to the next step. So next step, there's a little bit more to do, as you can tell. Okay, now we are touching to the core features of the class. Okay, the apply method, and then the next one is going to be the undo method. Okay, so what's happening? What kind of compilation error are you getting ready? And I'm going to put the code back on the screen so that you can keep an eye on it too. Oh, so that should be a typo somewhere, like looking for an expected. So it's expect you to close the parentheses. So that can happen here, here, or here. Like for example, make sure that you have those parentheses matching here. Okay. If you put your mouse over parentheses like that, it should show you where is the closing parenthesis. So that's a nifty feature for an incorrect caps. Okay, perfect. That works too. Meanwhile, Andreas had a question. So the extends array string transform is telling the class that it will inherit the object from the main method. No, it's telling the class. So this is telling that it's saying that the class named series of transform inherits from the superclass array list of string transform. Okay. So what does that mean to inherit from a superclass? That means that everything that superclass knows how to do, every attribute it has, every method it has, is going to be available inside series of transform. So for all intent of purpose, if you ask me, I have an object of class series of transform, what can it do? And I'm going to answer to you, it can do everything an array list of string transform can do. So it has the add method, it has the contains method, the clear method, all of those methods that are available to array list, plus more stuff. For example, it has a validate method that I'm adding here, and it's going to have an apply method that I'm going to add here in a few minutes. Does that make sense? So, and I'm going to leave you time to type a follow-up question, and I'll come back to it, okay, if you say something in the chat window. But meanwhile, let's take a look at the next method we have to write. So it's going to be the apply method. So this is the one where you give me a string, I pass that string through every object in the series of transform, and I give you the end result. So they tell me at the beginning, you display this on the screen, this message right here, okay? So sure thing, I can do that. I'm going to start with a system.out.println, and then I'm going to go back to the chat and catch up with your update, okay? So system.out.println, there we go. And I want to display that specific message that was given to me in the instruction. Save, build. Why would extending just string transform not work, since it still has all the same method inside of it? Oh, so watch out, okay? A string transform is a class that represents one transformation. An array list of string transform is an array list class that is capable to hold a list of string transform objects. Two completely different things, okay? So if I write here series of transform extends and I write only string transform, that means that, okay, here's string transform. It can transform one string, and series of transform is just a variation on it. No, it's not just a variation on it. It's not a specific type of transformation. A series of transformation is a list of transformations, right? So this is why I have to say series of transform extends an array list of string transform. Okay, very important stuff there. It's not the same if we replace just array list of string transform by just string transform. Okay? All right, cool. All right, back to this method. The first thing that I'm asked to do is pretty nice, okay? Display a message followed by the value of the parameter string. So my parameter string is named input. So I'm going to go here and I'm going to say plus input. Okay, so far so good. So that was just the beginning for. It will then iterate over the array list. So we've seen how to iterate over the array list with a for each loop. So I can pretty much use the same pattern here and apply in turn each of the string transformation model by the various objects stored in the array list. Okay, so for this exercise here, I'm going to summarize you pretty much what's happening. But you would have to read this, and this once you're done reading this, you would have to start reading pretty much in string of transform what the method apply does, what the method undo does, what the method get result does. Okay, so instead of reading through all of them, I'm going to give you a summary here for the sake of saving a little bit of time. Okay, so if you read those blurbs, you're going to realize the following thing. You are going to realize that inside of here, okay, if we want to go through the list of transform and we want to apply every single transform one after the other, we are going to have to tell the transformation, each transformation object to apply the transform using the apply method. But then the apply method, you're going to realize it doesn't return to us the result of applying the transform, which this morning somebody said, well, why doesn't it? It would be natural. Yes, it would be natural. It would be simpler, okay? But we had to structure it a little differently, and you are going to understand why next session when we deal with the log file, okay? So for now, bear with me. We kind of chose an approach that is a little maybe unnatural, a little surprising, but it's going to pan out really well when we do the log files later on. So what is this weird method that I'm talking about? Well, let me show you code actually instead of trying to narrate it. That will be easier to follow, okay? So after displaying that initial message, I'm going to use a for each loop. So here's the base for my for each loop. And I'm going to say for each string transform ST inside this, the same pattern that I was using before, right? What do? I'm going to apply the transformation inside that object. So ST, which is my string transformation, my reference to the string transformation object, dot apply. Apply it to what? Well, the first time around, I would like to apply it to input. Okay, so that's the first time around. But then when I iterate again, I don't want to keep just applying it to input. Once I have applied it to input, I need to get the result out of this application. Okay, and this is what I want to apply the next transform to. So how do I do this? So this is where the getResult method comes in handy. Okay. Once you are done applying a transform to a string, you can call st.getResult. Okay. And it takes no parameter. And that st.getResult is going to return to you the transform version of the string. So if I say I pass the input, okay, I can say, for example, tmp equal, and this is going to be the result of transforming input with this particular string transformation. Okay. So where is tmp coming from? Well, I need to declare it. So string tmp, and at the beginning, I'm going to say tmp is the same thing as input. So that's going to allow me to write tmp here. Okay. So at the beginning, and I just realized I have an ugly typo here. Hold on, transform. There we go. At the beginning, you give me an input. I put it in TMP. I pass TMP to apply for the first transform to modify it. The first transform stores internally the result, but doesn't return it to me. And then I ask it to return the result to me. And now it gives me back that result. And I store it in TMP. So what? So that the next time I iterate, guess what is going as the input of the next transform? TMP, which is currently the output of the first transform. And then I'm going to get the output of the second transform. And guess what? Reiterate again. Guess what goes as input for the third one? The output of the second one, and so on and so forth. So the output of the previous transform is fed as input to the next transform. And we keep doing that over and over as we go through the series of transformation. And by the time we are done doing all this, guess what's happening? Well, TMP is going to be the end result. TMP is going to be what pretty much the result of all of applying all those transformation is. So I can say here return TMP, and there we go. Okay, so I know I had already one typo that I caught on the fly. So let's see if we have other syntax error typos to correct. Sounds good. All right. So this is the apply method. So question from Michael, 113. What do you mean 113?
Is that the syntax where
oh, line, sorry. Never mind. I should have cut that. Okay, so line 113, yeah. You have a data type, name of local variable, equal parameter. Yeah, that's exactly what we are doing there. Absolutely. Sorry, I was thinking 113 is a code for something, or I don't know what I was thinking. Don't ask me. Anyway, so we have like this method apply. Now we have the structure for applying all of the transform to a given string and successively, transforming it until we reach the end of the series, and then we return that result. Now let's take a look at the next step. The next step is undo. It's the same thing, but completely reverted, right? So instead of going from the first transform to the last in the chain, we are going to start with the last and move our way to the first. So instead of iterating one way, we are going to iterate in reverse order, okay? And that makes sense. If I do one modification, then another modification to an object that I want to undo with my work, I'm going to start by undoing the last thing that I did and then undoing the one before that, right? So this is exactly why we have to iterate backward in the series of transforms. And then instead of calling apply here, we don't want to apply the transform. We want to undo it, right? So we are going to have to call undo. All right. So let's take a look. What is it going to look like? So we are going to have the same for loop structure, but we cannot use a for each loop anymore. Okay. For each loop was okay when we were going from start to end of an array list. But if I want to iterate in reverse order in the array list, I need to use something different, okay? So I don't have much of a choice. There's something different that I need to use here is going to be a traditional for loop with indexes. So here we are. So this is going to be a review of how to traverse in reverse order an array list using just index notation. So for I equal, this is my array list. I'm going to ask for the size of the array list, test.size minus 1. So the size minus 1 is always the index of the last element. It's true in an array, a regular array. It's true in an array list. It's true in a string, okay, when you talk about the index of characters. So this is where I start. Then at every iteration, I'm going to decrement I by 1. So my index is going to go 9, 8, 7, 6, and so on and so forth. And then my condition to continue iterating is going to be, as long as I is greater or equal to 0, keep going. So that's a loop that's going to use the indexes starting from the last index, going back to index 0 for my array list. So why are we using des and not des plus array name? Because it goes back to this part of the code here. When I said my series of transform extends array list, okay, that means that any object of class series of transform is an array list, okay? The other approach that we could have used that I mentioned sooner was we could have made one of our attribute, for example, my list, whatever, we could have made one of our attribute, an array list. And then every time we try to refer to the array list, we would say my list dot add, my list dot size, and so on and so forth. But now that we have not used an attribute, now that we inherit from array list, the object on which this method is called itself is the array list. That's why we have to use the keyword des. See what I mean? So it's really because of this decision that we made here to inherit. So Java automatically knows this is referencing to series of transform. So the variable des does not refer to a class, so it doesn't refer to series of transform, but it refers to the object on which you called one of the method. So if somebody writes, in the main something dot validate, okay, something being a reference variable referring to an object, when I execute the method validate, inside of the method validate, the des keyword is a way for me to get the reference to the object on which the method was called. That's the primary function of the des keyword in Java. Cool. All right. So we were done with apply, I think. We were talking about getting started on undo. So I have like a basic loop right now. Okay. There's more to do, but at least we have a basic structure to start off with. So what are we going to do inside that loop? So I'm going to use my previous method as an inspiration, right? We did st.apply. So now we need to do st.undo. Okay. And then we kept getting the results. So yeah, I would like to do the same, undo, and then get the result. But I don't have a variable st anymore because I'm not using an array list. What I have is an index. Okay, no problem. So string transform. I'm declaring a variable string transform of type string transform named st. Okay, string transform st equals, and what I want to assign to that, I want to take my array list and ask my array list to get me the element at index I. And if you don't remember, how you get an element at index whatever inside an array list, this is when it pays off, to have that page in the textbook where you have that table that summarizes all the method available on array list, or at least all the method that we've used in this course, right? And then you can quickly flip through the page, go to your textbook, go to find that table, and refresh your memory. Okay. Can't we do a des.getI.undo? Yeah, that's a good question. So here's what I was going to do. I was going to do st.undo after what? Okay. st.undo, and I need to pass to it, something like TMP. So we're going to work on that. But instead of doing first create the variable and then do the undo on it, I could actually try to do all of in one shot. So it would look something like this: des.get index I dot undo TMP. That would work as well. Okay, no problem. I just don't save the reference to the string transform object, but that's okay. All right. So for this to work, of course, just like with the previous method, I need a string TMP, and initially string TMP is going to be equal to input. Okay, and then I'm going to pass it through the undo step, for each of the method, but I still need to make sure that the output of one step is the input of the next one in the chain, right? So how am I going to do that? Get result. So this is where this approach here would be a little bit problematic. It's not really super problematic, but I would have to rewrite, des.getI. If I save the result of calling des.getI in a variable like st, then I can still use it to do st.result. Get result, actually. Sorry about that. So let me fix that. There we go. Get result. Okay. So saving the reference in st this time around, it can be useful, but we could still make it work without this. And then what is going to be assigned what is the result of calling get result going to be assigned to? TMP. So that now TMP can be fed into the next step, the input of the next step, and we get the result in TMP, and then we feed it to the next step, get the result, and so on and so forth. Okay. What am I missing? A little error, not error message, but a little message here that I'm supposed to display. So I'm going to grab that. And every time I start executing the undo method, I'm supposed to do a system.out.print ln, and then in between double quotes, whatever the instruction asks me to display, which is this message followed by the value of input. And there we go. It would be. All right, there was a little delay there, cliffhanger. All right, what else do we have? So we are done with this class, and I think, let me double check, I think this is where we finished this morning. So we have time to go a little further, or we can open the floor for Q&A, okay? It's totally depending on the number of questions we have. If we have questions, let's go and answer the question like we did this morning. If not, then we may have time to start already the second section. I'm not worried about the two sections being in sync, since we are this is our last two sessions right there. So question from Brian in the chat. So what is getting undone in the method? Or should I not look into the method name that much? No, you should look into the method name and also the method description, right? That are like in the comments like this. So if I scroll down here and I look, for example, to apply and undo, okay, it's telling us that these represent in the class a string transformation, right? These represent how the string is going to be manipulated This is where the job actually gets done, okay? The role of the class, let me scroll back up, the role of the class series of transform, when you call apply on it, the apply here is just saying, okay, I'm going to apply all of the transformation. So it looks at all of the transformations, one after the other, and tell them to do their job. So what we still have to write is the method apply inside the class string transform that's going to take a string and modify it in a certain way. Okay? And same thing for undo. So when I provide you with a string transform, if I say, for example, okay, let me implement a subclass of string transformation, or string transform, sorry, and it's called uppercase. And that uppercase class is going to model a string transformation where I change all the lowercase into uppercase. Well, if I do that, my apply method is going to go through every character of the string, turn them into uppercase. My undo method is going to go through all the characters of the string, turn them into lowercase. Does that make sense? We still have to write that part, okay? We have processed the entire chain, but we have not processed individual transform yet. Question from Steven. For the undo method you just did, weren't you supposed to change return input to return TMP? Yes, it sounds absolutely like something I should have done, and I apparently completely skipped over it. There we go. Thank you for catching that. That would have cost us like probably 10 minutes of debugging later on when we're running this. Okay. So awesome. Thank you so much. Control S, Control B to build. We have the undo method here. We have the apply method. So pretty much we are done with this class series of transform. So I'm checking, no questions. So we have enough time to kind of like get started at least, you know, in the next class. So I would like to do that. The next class is, sorry about the scroll back up and down. There we go. The next class is string transform. So that one is going to be also a very important one. It's supposed to model a transformation that you want to be able to apply to any string, okay? So it's going to have, let's take a look at the method it features, okay? It's going to have a constructor, it's going to have an apply. When you say apply this object, you know, on a string, it's going to take that string, like hello, for example, is going to apply whatever transformation we implement here to the string and store the results somewhere. That somewhere is going to be an attribute. So you remember when we were applying to the same series of string, you know, every object in our series of transform, I told you the apply method, that one doesn't return a string. That's the one I was talking about. So this one doesn't return a string once it's done applying its transformation. It just stores it inside inside an attribute result. And yes, to answer Nicolas' question in the chat, we will definitely be finishing this on Thursday. Okay. So right now I'm just giving you a head start in the next class. You're going to see that this is pretty much where we stopped this morning. And then we're going to, if you have questions, I'll answer your question, and then finish definitely Thursday. Okay. All right. So that's what's going to happen here. We are going to do things like, for example, my result being an attribute. Okay. Result equal. Well, if I don't do anything, the easiest, most stupid version of the apply method would be to do something like this. Okay. Result equal S. So that means that the result of applying the transformation that this class represents is pretty much nothing. But you are going to see that the instruction asks us to do a little bit more than that. Okay. So let's dig in. Since we are talking about apply and it makes sense, let's dig in the instruction for the apply method. So for applying and undo, we are going to follow the same kind of logic. So you see that there is one set of instructions that tell you what to do for both apply and undo. The class string transform, by default, it represents like a neutral string transformation, the one where we actually do not modify anything. So why? Why do we do this? Because that class is going to represent not no modifying of the string, but then we're going to have subclasses that are going to do actual modification to the string. Why did we separate things like that? What is the benefit of having a neutral, string transformation class that is a superclass to all others? Well, the benefit here is that this way we are capable to actually use polymorphism and all of that good stuff, okay? And we are capable to factor into that superclass all of the code that every single subclass is going to have to share. And in our case, as we are going to see next session on Thursday, in our case, that means, for example, the code that allows us to document into a log file, to write into a log file, every single operation that we process on strings. So every time you go through an entire series of transform, every single transform object, when it modifies the string, is going to say, here's a timestamp. At this date, this time, I modified this input string into that output string. That's what I did. And then the next one in the chain would say, at that time, that date, etc., I modified this input string, which would be the output from the previous one, into this other output string. And so we are going to have a log file that is going to show you us step by step what are the transformation that our string went through before to reach its final result. So that code to write into a log file and stuff like that, it belongs in the superclass because every single transformation class is going to have pretty much the need for the same code. So instead of repeating it, we just put it in a superclass and we are done. So let's try to just implement apply and undo, and then we'll stop for the session, okay, because we are reaching the end of our 2-hour slot. But let's just try to apply a very basic form of the method, to implement, sorry, a very basic form of the apply and undo method. So I already mentioned here that I would like to have an attribute result. Well, I kind of cheated because, yes, we do need an attribute result. As a matter of fact, the class requires us to have an attribute result, okay, and then an attribute input. And these are going to store internally what was the input string that was passed to the object to transform, and what was the result of that transformation. Can you show apply from the superclass after? So this is apply from the superclass that we are about to write here. Okay. Remember, we are in the class string transformation. Okay. And in that class string transformation, string transformation is a superclass for letter transformation and reverse transform. Okay. So I see that you got stuck doing the record and write log. We're getting there, but unfortunately next time. So if you want some help with that before, come to office hours, okay? And I'll be glad to help you, or any of the here will be glad to help you out, okay? So going back to Andre's question, we are here in what is going to be our superclass, string transform. If I scroll down, you're going to see that after that class, reverse transform extends string transform. Okay. So yeah, I can go back to the previous class after to show you how we use. Yeah, I get it now. To show you how we use this apply, definitely. Okay. So right now we are here trying to write this apply. So I was scrolling back up to look at the list of requirements for attribute, and I see that I need a string input, a string result attribute, and I think all of these need to be private. So let's write those first. Private string result. Private. So I'm just declaring attribute here in the string transform class. String input. So the instruction explained that input is supposed to be whatever string you have to modify. You save a copy of it there. And the result is supposed to be whatever string, whatever result you obtained after you modified the string. So we already said that this string transform class is going to model the most stupid transformations, the transformation that does nothing. So I can say that my input is whatever you gave me as parameter, and I'm going to say that my result is whatever you gave me as parameter as well. Okay? So it sounds really stupid, right? It sounds like a very stupid transform, but just bear with me for a minute. How do I undo a transform like that? Well, that's the advantage of implementing a very silly transform, is that it's easy to undo, okay? If you give me a string s that you want me to undo, since my transformation was doing nothing, I'm going to say, well, the input that you gave me is s, and the result of the transformation that does nothing, or I should say the result of undoing the transformation that did nothing, is still s. So I have an apply and an undo method that updates the attribute input and result based on what you give them. And now just to finish the session, and then we're going to go back to how those methods are used from the previous class, okay? Just to finish the session, if I was doing only that, yeah, that would be kind of pathetic, okay? I have to admit. So we are going to add another feature here. There's another method that we're going to write next time called record log data, I think. Compiler will tell me if I'm wrong, okay? And record log data is going to pretty much record for me information about what's happening. You know, what is the time that the operation is being performed, what is the input, what is the output, and it's going to be based on the parameter s, so I'm going to call that method. And that actually makes the whole difference, because in the subclasses, I'm going to override apply and undo. That's what's going to happen, okay? In the subclass, I'm going to say, oh, you want a subclass that apply a transformation that actually reverses a string? Sure. Let me subclass string transform that does nothing, and then I'm going to override apply and undo. But as I override them, I'm going to call the superclass version of apply and undo, which is going to trigger this transformation that does nothing, but also make sure to record all the data that has to eventually be committed to the log file, okay? All right, with 3 minutes to spare, we are going to close here. But before we close, let me just go back and address your question, Andres. So in the previous class, so series of transform, this is the context in which I was using the apply method, okay? So remember, the series of transform contains is an array list of string transformation object, okay? So we can have access to a list of string transformation object. We go through that list and we ask each string transformation object, apply yourself to that string. And now we know what that means to apply, right? We've seen, we took a peek to the detail. To apply means that this string transformation object is going to store internally that it was asked to modify the string. So it's going to record it in the input attribute. And then it's going to record in the result attribute the result of the transformation. And guess what? When I call get result, that's exactly what's going to happen. I'm going to get back the value of the result attribute. Do you suggest going over there multiple times, or don't press the panic button? Yes. Going over this. Tell you what, ask me whatever question you have. We can go over this as many times as it takes for you to be comfortable with it. Okay. Especially if you mention panic button. I don't want panic buttons. Just tell me that you are stuck or lost, etc., and we're going to work you through this. Okay. Yeah, no problem. So keep in mind also that, so for those kind of questions, I would suggest come to me first, maybe. Not that the TA cannot help you, but like I've been working on preparing this, so I know it better than the TAs. The same way I tell you, when you have a question about a grade you received, go talk to the TA first because they graded your work, so they know better what they're talking about, okay? There's no chance of misunderstanding between me and the TA. Same thing for here. If you have question about this, please post on Piazza. Come see me. I have office hours like in very short time, just time to grab something to munch, and then I'll be back at 7 to 8 for office hours. Don't hesitate to drop by, and we can go over that example again. I can try to, to rewind a little bit, find the spot where you got lost, and then fill in the blank from there. Will we be going over polymorphism and exception and file IO with command line next class? Not command line, okay? I'm not going to do command line, but we already use polymorphism here in our array list. we are going to use exception and file IO to finish up that fake exam during the next session. Okay. I'm getting a compile error saying it cannot find input and result. Did I miss where we initialized them? Probably because I kind of did it sneakily here. So at the beginning of the class, string transform, okay? If you have been following along, it should be around line 170. You need to declare those two attributes: private string result, private string input. Okay, and now your compilation error should go away. But if it doesn't, let me know, Andres, okay? Brian, I think only issue is understanding the instruction for each method, but I should be fine with practice. So again, look at the instruction again, maybe later tonight. Don't hesitate to come back and say, those instructions are not clear. I need you to give me a good idea of what's going on there. And I can definitely help you with that during office hours. Okay, no problem. So office hours tonight, 7 to 8 p.m., okay, as we have been doing for the last few months. And then tomorrow from 5 to 8 p.m. And then the day after, we have our second review session of the week, so morning, afternoon. And then we'll have also office hours 7 to 8 p.m. Okay. It says interface expected around line 60. Ooh, line 60 is towards the beginning. So interface expected, these are curly braces gone wild. That sounds like curly braces gone wild, okay? Because by this time in the file, we have opened a class, we have opened a main method, right? And if you look, all of this is inside the main method, right? And they close on 68 and 69. So make sure that you have that part already, like this. The main that closes around line 68, and the first class, the public class, that closes around line 69, okay? Let's double check that, and then what we can do, I'm going to stop the recording anyway, and then we can address any question that you have that you didn't want to get recorded, or you can share screen, okay? So let me stop the recording, and thank you again, everybody, especially if you have been listening to this offline. All right, recording over. Oh, you declared them inside the constructor? Okay, that would do the trick. Yeah, that would definitely make that happen. So I stopped no, I didn't stop the recording. I stopped the screen sharing, not the recording. So let me stop the recording.